Solve a root of x in bracket root of x plus 1 is equal to 6. So you solve for x. We say solve for x. Solve for x. Then part B we have we have 3. This is 3 root x. We have 3 root x. Let's not read it as cube root of x. It is 3 dot, actually 3 root x plus 5 over root x is equal to 16. So those are the two questions. So solution, we start with 1, part A, solution part A. Here we can decide to square everything. Here we can square here, what is here, and square what is the other end. So if we do that, we are going to end up with x into x plus 1 is equal to 36. X, first case is x into x plus 1 is equal to 36. Because we are squaring both ends. We are squaring, okay, that's the first attempt. We are squaring both ends. And if that's the case, then let me see. Let me drop this approach for now. It's going to look a little complicated. Let me say, let root x be m. Let root x be m. And if we let root x be m, then it will mean that we have m into m plus 1 is equal to 6. Because now if root of x is m, then we have m into m plus 1 is equal to 6. It's equal to 6. This means that m squared plus m minus 6 is equal to 0. So we want two numbers whose product is minus 6 and sum is positive 1. So that has to be positive 3 and minus 2. So I have m squared plus 3m minus 2m minus 6 equal to 0. So I factorize, I have m here and say this is m plus 3, m plus 3 now, m plus 3, then minus what? Minus, it has to be minus 2. Then now m plus 3 again is equal to 0. That implies that m minus 2 into m plus 3 is equal to 0. Therefore, m is 2 or negative 3. M is 2 or negative 3. But m, we had to be that. So it means that but m is root x. M is root x. So m can be root -3 or root 2. But in this case, negative over root will lead us to a complex situation, a complex number which we are not anticipating at this particular point. But when you have that root to be a negative, it implies that there is no solution because the root of x can never be negative. So that just implies that where x is -3, there is no particular solution at that particular point. So in this case, we then say that m is therefore root of m is root of 2. That implies that m is root of 2. M is root just no. M is 2. M is 2. So we say root of x is equal to 2, implying that x is equal to 4. That's the answer. X is 4. X is 4. Now that is the solution. If you substitute them here, you should be able to get 6. Now that has to do with part A. Now I want to consider part B. Part B. I want to consider part B. Part B. That 3 root of x. 3 root of x plus 5 over root of x is equal to 16. Is equal to 16. You want to find the value of x. Now, here we see root of x is the LCM. We can multiply each term by root of x. So if I do that, then I'll be having 3x here. Goes this by this, 3x plus 5 goes that shall have cancelled that, is equal to 16 root of x. That is the first expression that I get. This means that I have 3x minus 16 root x plus 5 is equal to 0. Is equal to 0. Let m be root of x again. That will allow me to say 3m squared minus 16m plus 5 is equal to 0. So it means that I'm looking for two numbers whose product is 15 and sum is -16. Product 15, sum -16. Those two numbers must be 15. Those two numbers are -1 and -15. So I have here 3m squared minus m minus 15m plus 5 is equal to 0. So it allows me to say here, factorize m, so that I have 3m minus 1, then minus 5 here, and I say 3m again minus 1 is equal to 0. That means that this case is a case where then means that we have either m minus 5 or 3m minus 1 is equal to 0, implying that m is 5, m is 5 or a third. M is 5 or a third. It implies that m is 5 or a third. But m was this. So we say, but m was root of x. So it implies that if root of x is equal to a third, that should mean that x is 1 over 9. And if root of x is 5, that should then mean that x is 25. So those are the two answers that we have. X is either 25 or x is 1 over 9. So that is how we were expected to go about that particular question, and it is a continuation of our considerations of quadratics. So up to there, we meet in my next video.